So for this to be a parallel circuit, it has to have junctions. You'll have a junction here coming out the positive side of the battery, and that one shows you the start of the parallel section. And this other junction on the other side would show you the end of the parallel section. Okay, so the part between the junctions is the parallel part, whatever is in that. So your circuit could look like this, for example. This is still a parallel circuit, showing you that that's the start of the parallel section and that that's the end of the parallel section. The only difference is that within this top branch, you have two resistors in series, but that's still a parallel circuit. So the rules for parallel circuits, you must have junctions. And it's the junctions where the current splits. So if you took that as being your I supply, then that would hit that junction and split into a current I1 and a current I2. So to notice a parallel circuit, you'd expect to see these junctions where the current path splits and rejoins. The other thing you would notice in terms of the voltage is the same across every element in that parallel section. So if that voltage there, for example, was 50 volts, then the voltage across there would be 50 volts, the voltage across there would be 50 volts. Looking across to this other circuit, if that was 50 volts, this would be 50 volts, and 50 volts would be divided across these two series elements within that. Yeah? So it wouldn't be 50, 50, 50. It'd be 50 here and 50 for all of this, which you could then do a voltage divider on, as we've just kind of looked at. To get the total resistance, the formula that works for everything would be this formula. And you've got a button in your calculator to help you do that. That's your 1 over button. So usually, say it was a 20 ohm resistor and a 10 ohm resistor, you'd do 20, press your 1 over button, plus 10, press your 1 over button, equals, and then do it one final time to turn this bit upside down to get your RP. This method works for everything. There is another method which only works for two resistors. This method is known as being the product over the sum. The product because you times them in the top, and the sum because you add them in the bottom. So this method works for everything. This method only works for two resistors. Okay, so I think we'll do, let's have a look at working out this one. See, this is so can you work out the voltages across each resistor and the current through each resistor? Okay, so here is the working that I've done for this. So yours might be slightly different, and that's fine. So what I have done is to get my current I1, which is the current through R1 and R2. It's that current path there. So you can see the current through I1, R1 and the current through R2 would be the same. I've taken I equals V over R, so I've done I equals V over R1 plus R2. That's the total resistance in that branch because those two are in series. So in series, you just add them up. So 50 over 30 gets you 1.667 amps. I've used a similar method for the current I2, which is the current through resistor 3. I've done V over R3. So the voltage across that branch is 50, R3's got a value of 60, and I've got that current there. Now to check that I'm right, I've found my total resistance in my parallel circuit by doing 30 in parallel with 60, getting me 20, and I've worked out my supply current of 2.5 amps. So then I've taken these two, added them up, and these two do add up together to give me 2.5. So I'm pretty confident that they're right. Then on the basis of those currents that I've worked out, or the top current anyway, to get the voltage across each resistor, because they're in series, and I know the rule for resistors in series is that they have to add up to give me that 50. I've done V1 equals I1 times R1, so that's the current through resistor 1 times the value of resistor 1. So my current through is that 1.667. My value of my resistor 1 is 20, so that I1 times R1 gets me 33.34. For my I2, or my voltage across resistor 2, I've done I1, which is the current that flows through resistor 2, times the value of resistor 2. So I1 again, 1.667, multiplied by 10 this time, gets me 16.67. And then these two should add up to give me 50. So 33.34 and 16.67 gets me 50.01. So I'm okay with that, that's fine. And then for V3, because that's a resistor just across that supply, no calculations needed because it's just the same as the supply. Did we get that? Parts of that.